Here, right here, this, right there. So you got long-term bonds here, US market, but actually, as you know, the picture is here. And that was till September 30th, 2012. So now let's morph from stock returns and stock risk to portfolio risk. There's a small adjustment we have to make, and one of them has a very major implication. So assume a two-stock portfolio, and I know it's probably boring to maybe all of you, so I'll just show it to you. 50,000 in Alta, 50,000 in repo. So calculate RP. Notice the I has changed now to P. What does this hat mean? This hat is reminding you that these are not realized returns, these are expected returns. So please keep a note of that. It's very important that you as investors understand that there is a big difference between the two. I mean, think of the investors who invested in 2007 December. Were they expecting a minus 40%? If you were expecting a minus 40%, or if you knew there'd be minus 40%, what would your investment be in? In the treasury bill, right? But you invested in the market or in individual securities because your expected return at that time was positive. So the expected return and realized return are big difference, and this difference will not be highlighted by most of the advisors. The good ones will, but the ones who just want the commissions, they will sort of gloss over it. I know I'm on tape, so I can't say more, Yeah. But you know what I would say, I'll just make fun of it. RP is basically a weighted average. You're actually already doing that. See, it's not so easy for you to see that. That's why we do the weighted average. When you're calculating your betas, you're doing that. So for your returns, I mean, if 90% of your portfolio is in Apple and 10% is in Samsung, you can't do equal, right? You have to do 0.9 times Apple returns plus 0.1. In this case, so 17% is for Alta and 1.7 for repo. So your expected return on the portfolio is 9.6%. And just to give you the basis, I always show you the theory too, I like to use computing, but I want to show you the theory. There's another way to do it, the old-fashioned way. The really old-fashioned way is you have your return for Alta, for repo in the alternate states. You can calculate the portfolio return. 0.5 times negative 22 is minus 11 plus 14, that's 3%. And then, see, that's where you do a little bit of the vector multiplication there, That's n times 1 times 1 times n minus n times 1. And here are your portfolio returns and then your probabilities, and you get this 9.6% again. No big deal, guys, but it's just, instead of looking at the individuals now, we looked at the portfolio return in each state. 3% has a 10% chance of happening. 15% has a 10% chance of happening, comes over to 9.6%. This is the slide. I know we're sort of around break time, but just give me a minute. This is magic. I'm going to show you guys magic. All of you. Here, there. This is what retail investors are not doing. They don't do it. And this is what makes the difference. This is the basis of diversification, but Markovitch diversification. Why the simple act? So the net, I'll let the cat out of the bag. Why the simple act of combining securities lowers your portfolio risk? This is literally, like literally making gold out of dirt. And we know there's a problem with that analogy there. It doesn't happen, but this one happens. What is the standard deviation of the portfolio? Well, standard deviation, we can invoke the standard deviation formula. It's 3% we know. The average we just did two different ways, 9.6%. 9.6% is your average expected return. And the different states are 3%, 6.4, 10, 12.5, 15, and that. So we square it, multiply it by the probability is 3.3%. Fair enough for this portfolio. However, notice, So the standard deviation is much lower than what was there for either stock. And remember, this is a two-stock portfolio we're looking at. For stock 1, the standard deviation was 20%. For stock B, the standard deviation was 13.4%. Remember that? Or should I back up? No, actually here. Standard deviation 20%, standard deviation 13.4%, okay? So if you average it, what should you get? 16 something, right? The average of these, the average standard deviation, and remember I threw in something there about averaging the CVs. Cannot do it. You'll see that Y here. Why is the average 16.7%? Well, half of 20% is 10, and half of 13.4 is what? Like 6.7%. 6 2s are 12, 7 2s are 14. That's 13.4. Wait a minute. We average the two standard deviations, and that's 16%. We put the two in a portfolio, and we calculate the standard deviations based of the portfolio returns that are based on the combination of these just two assets. We get 3.3%. Where did that extra amount of risk vanish? And did it vanish? It vanished. It really vanished. So you're getting something for nothing. By a simple action of yours, by just combining two securities, you're getting that. The caveat here is, this is possible only if the correlation between the two securities is not perfect. If it's perfect, it's not going to happen. Therein enters the whole thing about correlations between securities, and something associated with that is called a variance-covariance matrix. Now, I'll give you a basic feel for that, but it's beyond a little bit scope of the class. But those of you who are interested, you can talk to me about it. Is a lot of optimization software is, and in your portfolios, if you now, you'll make some sense when you go and revisit. You should revisit some of the things that I posted to create the portfolio. You want to populate your portfolio with securities that have sort of minimum correlation with each other. But it gets difficult, It's like, how can you look at one security and then you have another, and so there are different ways. If you look at the Mac portfolio, I've actually proposed to the whole industry the first time that you can have a whole matrix and you can come with one number, something called generalized variance, which is the determinant of that matrix. That'll give you one number, and in that case you want to maximize that. You want to maximize the difference between the Euclidean difference between any 2 points. So this portfolio provides average return but much lower risk. The key here is negative or less than perfect correlation. Basically, the variance of a portfolio, this is a formula, is the weight in if a two-asset portfolio, the square of the first weight times the variance of the first asset plus the square of the second weight times the variance of the second asset. And here's the key here, is 2 times the product of the weights and something called the covariance between 1 and 2. Now, covariance between 1 and 2 is itself extended to the covariance between two assets is the correlation between the two assets times the standard deviation of the two assets. Now notice, this will collapse to what we are familiar with, right? If a plus b squared is what? A squared plus b squared plus 2ab. So if this covariance 1, 2, if this correlation is 1, then you just have variance 1, variance 2, and you can write down the variance of a portfolio as the average of the variances. So I'm just saying, this, I'm not going to ask you this in an exam or something, but this is just the reasoning behind why you cannot average it. You can average the two. You can average two standard deviations if and only if the correlation is 1. Because see, here is the average here. This will work. If that is not the case, you won't be able to average it. And the investor will stand to benefit from the lowered variance of the combination of the assets, which is the basis of Markowitz diversification. Just to finish this topic here, so the standard is the same thing. I already said that. The standard deviation is the square root of this. So you got this term. Just think of this term. Think of this as A and think of this as B. A plus B squared. So A plus B squared, the square root of that is basically A plus B. And once again, I'm saying IFF For those of you who want to know, IFF is actually if and only if. So the military people probably think identification, friend and foe or something, right? Identification, friend or foe, right? And so your standard deviation is this. So if the correlation is, now notice, there was some work done, you can actually take two highly risky assets and you can make a riskless asset. Once again, for that what is required is that the correlation coefficient is -1. If the correlation coefficient is -1, then portfolio standard deviation is basically W1 times sigma 1, which is basically the weight in your first asset, times the standard deviation, minus W2 sigma 2. And so, as you can think of it, this number can exactly be equal to this, and your sigma will be 0. So you can take two highly volatile securities, and you can actually have a riskless portfolio. Then it enters a lot of portfolio, computational finance, portfolio math in there, is how do you balance the two. However, this is practically impossible since very few assets are perfectly negatively correlated. This correlation, is not a big deal, guys. Here's a formula for that. You think I type that formula in? No. You go to Excel and you just type in Corel, and it'll give you in the help file, it'll give you this formula. It's basically the difference between the variable's value minus the average and some statistical adjustment. And you don't actually have to do it in Excel. You just do equals Corel, and you pass in the two arrays, and you should be good to go. I'll talk about it more in the next section here. Let's take a few minutes break. Thank you.